Okay, cool. I think we're finally good to go. Laptop seems to be increasingly struggling running all of these things. But I think we're up and running now. Hopefully sounding okay. Hopefully working. So we're going to dive back again on the granular business. Part 5 now. Wasn't entirely sure it'd go for this long, but just keep finding more things to do. Last time we did pitches, adding a few different ways to scale and quantize randomized pitch. This time we're going to be having a go at building a LFO and hopefully also doing some drag and drop sampling. Probably for the first time since starting this, I actually had a bit of a mess around outside of these sessions. I wanted to send the device over to people because it was actually doing some kind of fun stuff. So I did a few edits and ended up getting it looking a bit like this. I'll just zoom in on Ableton, so hopefully it's a bit easier to see. But yeah, made quite a few improvements to the UI and added a bit more functionality as well. So if possible, we're going to try and get somewhere near the point I've got here, which is a lot more tidied up, a lot more usable, and a lot more useful to actually start sharing and giving it out to other people. So with any luck, the idea is to try and get somewhere around here. If we can squeeze all the different things we need to get in. But I'll still try and keep it fairly informal and not too well practiced, so it's not a proper tutorial where I'm having everything perfectly worked out ahead of time. Sometimes it's interesting to know how you deal with the mistakes and weird things you run into programming Macs. So let's go back to the earlier version, which is how we left it before I did some work on it yesterday. And yes, so last time we did a load of work adding this scale section over here, which ended up working really nicely, I think, actually, in a few practice runs we did. Messing around with different pitches, doing some interesting improvs with scales and randomized notes coming around and reharmonizing and kind of improvising with what samples we loaded in. The other thing I improved a lot in the version I showed you just before was previously we added this automatic transient setting thing where the start position, the sample playhead would automatically jump to where the last recorded transient was. And we also added an incredibly basic LFO, which allowed us to scan through the start position, which is kind of a classic granular thing. You often have, scan as it's often called in a granular synth, but basically it just means applying an LFO to start position. So as it's kind of granularizing, it will scan through the start position, which allows you to get kind of time stretching-esque effects, particularly like the texture warp mode or the tones warp mode. In Ableton, you might be familiar with if you kind of extremely expand a sample and start messing around with some of those settings in the warp mode, you get basically granular effects, because that's effectively what it is kind of under the hood. Although a bit different to this one, it's also got some elements of like a phase vocoder where the grains you're playing are kind of lined up and to play in split over a period of time and stuff to get that slightly better kind of time stretching sound and to get it work a bit better as time stretcher. We're not really particularly focusing on that, so it is a bit different to something like Robert Henke's Monolake's Granulator, which is definitely a bit more focused on that exactly. So a few things I did tidying up wise after messing around last time, which I'll probably just dive into some of them and get a few of them working. So one of the things was I noticed when I was using the audio analyzer input to try and get an idea of where I should set. So in this audio analyzer section, you might remember this is what we use to, so far, just to do something like triggering the start position to move to where the last recording point was, but we'll add a couple of other things that it's going to do in this video. In the example I showed you at the beginning, I'd actually got the audio analyzer and the threshold on and off of transient detection to do stuff like trigger when the granular engine actually starts playing. So whenever it detects a transient, it can start playing and stop, or the inverse, so it's almost like a sidechain. And I also got it to do auto recording with that function as well, which is great, so we'll add that. But I did notice when I was trying to gauge where to set the high threshold and low threshold to detect the transients, it was a bit tricky and misleading, because this gain meter here in the audio analyzer section is actually directly after the gain level, before we actually hit the filter or before we hit the smoothing or sliding. So it actually was quite hard to look at that meter and work out where to set the thresholds, because this meter is before the smoothing, and smoothing generally kind of lowers volume as well as the filters probably will to some degree. So this meter looks in the UI like it's after those functionalities, but it's actually before, making it hard to judge where to set those values, which was kind of the whole point of it. So I did actually chuck this down below a bit, actually down below the smoothing, and I found that really helped. Now you can see the meters properly logarithmically smoothing off, falling off as to do with this full setting here, and this allows us to kind of basically set the transient. We should now see if we make transients, yeah, you can see just about there is probably minus 6 dB, here's not, so it matches up better with detecting the transients and allowing you to set these values. The other thing with this scope here, you know, it's a nice little simple oscilloscope, but it's a little bit simple, it's a little bit ugly, not particularly great, so I did actually replace that and something else in the patch we'll replace in a sec, with a good old friend, the multi-slider object in Max. Just a standard Max UI object, but it lets you make interesting multi-slider displays. So you can, I don't know what's that number, but yeah, you can make multi-displays, kind of even draw functions. I kind of make a slight ADSR function with it or something like that. But yes, you can also make it do scrolling. So if we set it to scroll mode instead, line scroll I think would be good for what we want. And if I plug it into the snapshot, 'cause this is a data style editor, you should see there we're getting a kind of scope matching my voice. But to my eyes that looks a lot better and a lot more usable. So this automatically goes from -1 to 1, but if we remember, with an envelope follower we've made it be unipolar only, so we're going from 0 to 1. So if we change the range from 0 to 1 instead, be a bit more usable, and I think we seem to some reason be going for a black and orange kind of colour scheme with some things so far, so ooh, that's the wrong one. So why not go for that instead? I think, ooh, that actually looks a hell of a lot better. And the user interface kind of small, scrolls smoother, looks a lot better. And why not? Yes, I did a lot of UI tidying up in the other one and started just messing around, making, let's see, all of these things look a bit nicer. So yeah, using the inspector you can just hover over a color. I'm pressing Command C here to copy that color's information, select a color parameter in another object and just Command V, and you can actually change it. We could actually change that to black and white, maybe that might be a bit better, but for now we'll just leave it like it is. But yeah, a lot better scrolling interface for the audio analyzer. The only other thing I noticed, as you might notice as well, this is effectively a linear scale. If we have a look at the mic and the volume, due to the background noise of the fan going on, the background volume's actually kind of always sitting around here, roughly on this logarithmically scaled meter, which is what people are used to looking at when they're viewing audio. But you can see here, if I stop talking, it actually drops down to pretty much 0. And if I talk quite loudly, or make some clicks, it's actually quite hard to get it to hit the top. That's because this is scaled linearly, whereas most meters and the way people are used to viewing audio is in logarithmic terms. So it makes sense to my mind as well to change this to be a logarithmic view. Again, so it'll kind of match up with what we're used to seeing in terms of audio meters and gain meters, volume faders and audio software. And so it'll also allow us hopefully to a bit better tweak and set things like the low and high threshold if needed, because this will actually be a more true representation. If we imagine we had a volume scale on the left hand side, that scale would be logarithmic, as this would be as we are setting it in decibels, which is a logarithmic scale as well. I'm not really sure what the kind of best way to do it with, or the exponent you could do it with. There must be a better way. You could probably do this just using the scale object if I knew what the exponent was for a logarithmic decibel curve. But one hacky way I worked out, you can go, because this is effectively an amplitude, just linear amplitude at the minute, we can use A to dB control, and then we'll scale that decibel range, which I think in Ableton is generally -80 to 0, and we'll scale that back to be 0 to 1, because this multi-slider is from 0 to 1. And if we pipe that into there, and now get the slider into there, we've now got a logarithmically scaled multi-slider, which I think matches a bit better with the fader. We can see when the fader's sitting around there. We've also got the multi-slider sitting around there. Basically, it just matches up a bit better with the audio and allows us to hopefully see what's going on a bit. So tidying up the UI and making it match what we expect and what the controls are doing is something you do end up having to do with Mac's devices, to tidy them up and make them look a bit better. Next step, I wanted to tidy up this scale section. I did a bit of work tidying that up in the other bit and the other version that I did some more work on. Some reason when we were using the when we were designing the scales and this probability table concept for the scales in the other video, we ended up using itable and the table object, which is a great way to do probability tables very quickly, and we ended up using itable, which is a visual representation or a way to kind of design these probability tables. But it seems like there's some limits to the itable user interface object. You can't really make it any smaller than whatever height that is, about 64 pixels high for some reason. If there's pixels, I don't know. But anyway, you can't make it any smaller than that, which was limiting us, or limiting me, when I started redesigning this user interface section here. So I did actually replace that with a multi-slider as well. So this is a this is a pitch and probability section over here. This was our itable, which we were using to generate pitch probabilities, or a user interface way to edit them. Instead, we could go for a multi-slider, which I think would match our user interface better and look a bit better. And say we said, let's make a nicer default preset for this. So this is our list of pitches. Oh, live comment, pitches. Just get some names here as well. And this is going to be our probabilities, if I can spell properly. Let's get a a slightly better preset of what the pitches should load as. -12 semitones, an octave below. -7, I think, is a fifth below. -5 is a fourth. Second. The actual root note, and then we'll go up the same pitches the other way, giving us a kind of not major or minor scale, just using octaves, fourths, fifths, seconds. Nothing that particularly gives off a scale. Set that as the initial value, because that's a bit better than what we seemed to save last time. Save that in there as well. Call this pitches. We haven't really got into looking at scripting names here, but that's what this bit here is, scripting names. We might do something later on, messing with scripting names. Very powerful thing in Max/Max for Live, basically it allows you to give the object a name that any other device, any other object can access it from, and you can do lots of things with scripting names, from moving objects, creating new objects, resizing and reordering user interfaces on the fly depending what you press. You can actually send messages and monitor objects directly from anywhere else in the patch using their scripting name without having to create send and return. So we might do a bit of that later on, but for now I'm just labeling them, so hopefully they appear in pad of storage a bit easier, although they don't, because you have to label them, don't you? Anyway, we've got a default of that, which is 1, 2, 3, 4, 5, 6, 7, 8, 9 pitches by default. So this new multi-slider that we're going to use instead, for now I'll just set it to 9, although we'll obviously, I think literally just even doing that would allow the size to change. Yep, size, number of sliders, yep. So whenever we change this list, the number of sliders in the multi-slider will change as the sliders in here change as well. And we just decided that 9 was good. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so let's set the default to this to 9. And we were working with probabilities on a kind of percentage base from 0 to 100. So the range of the slider needs to be from 0 to 100 as well. And then we've got something very similar to what we have above. The difference is we can actually rescale this to all kinds of different sizes, which we couldn't do with the other one, which is a bit annoying. We need to wire this up. So by default, this iTable, just by naming it, by linking the table name between them, they automatically talk with each other. So editing this iTable here is actually editing the internal table in here. Not so automatically with the multi-slider, so we need to do a little bit of work to sort that out. So the table does actually output a list of what's inside when you send it a message. And what is that message? I think it's the message dump. Yes, so sending the table object the message dump will actually output all of the information in it. So I press dump. So that's a list. It looks like it gives you one after the other a list of all the pitches, which should be a list of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It kind of matches that as well. Yeah, 55 about in the middle, down to 38, up to 62 at the end. Yes. So we need to get that into our multi-slider. So for instance, if we recall a preset using pad of storage, we want this table to output its list of current values and to set the multi-slider to match. So any changes to the table, maybe through pattern presetting, automatically updates this user interface object, external user interface object, to show the correct values. So you might be familiar with other objects we've used. When we've used them, you need to basically, when you're editing this, you need to you want to set user interface objects. You don't. If we look at the help file for multi-slider, you can change what's in it by just sending a list of values. But if we're looking at this help file, you might be able to see whenever we change the values, it actually edits the whole list internally, and it sends out all the values onwards. So you can end up with kind of feedback loops where this table outputs its values to update the multi-slider display. The multi-slider display then outputs its values, which would update the table, and you end up with this weird feedback list, which hopefully wouldn't cause something horrible to happen, but it can cause errors in match, such as a stack overflow, which is when you create accidental feedback loops of data. So what you often do with user interface objects with Macs, which is what we have done with a couple over here in the patch, such as where we use prepend set messages, or just a set message. Basically what it does is it makes sure whenever you want to send a value to update a display, such as what we were doing with this user interface here, we have this LFO controlling and updating the start position visually, so we can get an idea of what the LFO range is. But you'll notice it's not actually sending out the value from the user interface. We're doing that separately here directly to avoid any issues or lag or slow down by sending it through. So similarly with the multi-slider, we want to get our info out of the table by hitting the word dump. We want to update the user interface in the multi-slider. So with multi-slider, we'd probably want to do something like prepend set, but I do happen to know, just from doing that handy little kind of bit of practice earlier when I added a load more to the device, you actually want to use the word set list. If you send the word set with multi-slider, as we can see in the reference in its help file, the word set, or the command set, takes two numbers after it, which is the slider value and what value you want to update it to. So we could say slider 0, update to 98 or something like that. So we could plug this in, plug a UI control there. I'm totally wrong. Slider 1. There you go. Off by one error, classic. But yeah, so the set message with a multi-slider will actually just change one slider by telling it what slider to change and what value you want to change it to. If we wanted to use the output of the table, like here, we actually want to use set list, which allows us to send a list of values and update all of the sliders in one go from a list. So we could do something like 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and send that into set list, and boom, we've set the entire list in one go. The output of table outputs individual numbers one after the other. This requires a whole list. So we're going to use another handy ZL object. We've touched on ZL objects a little bit before. ZL objects are objects which allow you to do work with lists in many different ways. You can take a list of numbers, sentence, values, whatever. You can chop the list up, randomize it, scramble it, take out individual elements of the list, all that kind of good list processing stuff. One happens to be ZL group. What ZL group does is it allows you to receive a number of values. In this case, it would be about 9 values, one for each of these pitch probabilities. You can group them into one list, and then when you actually hit bang, it'll output. So for example, if I hit the dump message to dump all those values have been sent into ZL group. They're just sitting there doing nothing. When I actually hit bang, we get that whole list in a nice list form that will work well with our multi-slider object. So now I can hit dump, I can hit bang, and we've just updated our multi-slider user interface object to match the values in this table. So we can get rid of our original iTable user interface object, which was a bit ugly and didn't quite work. Instead, we can now be using this nice multi-slider user interface object instead. We want to do a little bit of work here. So the first thing we do whenever we want to update display, we want to send the message dump to dump all the values. And then after we've dumped, we want to bang the ZL group object to output all of its values. So that should mean whenever I hit this bang, we update the multi-slider user interface. Next up, we want to do something the other way around, which is we want when we change a value on the multi-slider, we want its value to update the probability tables. One thing is this is only going from 1 to 100, and it's not floating point. We don't need these decibels. We don't quite need that much fine level of control. We just want to go from 0 to 100 in a percentage. With integers, we don't need floating points, so that's better. That's kind of what the table's expecting. Just changed in the inspector to just output integers rather than floating points. So out of this, whenever we change a single slider, we get a list of all the values of the slider. So this should be 9 values in a list, similar to what we had to send in to set the values. So we just want to set the table to this list of values whenever we change anything in the table. So if we have a look at the help file in table, I'm pretty sure what you need to do is effectively send it a list. The first number of two, you send it a list of 2 numbers. The first is the position in the table you want to edit. The second is what that value should be. So we can't just send this list into table, it won't work. We need to do a little bit of programming or processing to edit the list to get it to function correctly. So we want to send out individual values for each one and edit its position. That's fine. So there's a nice object in Max called list funnel. If you send it a list, like this value, list of values here, what we get out the bottom, if I use a print object, we should be able to see, what we actually get is it breaks down this list, and instead we'll output each one individually with its index prepended in front of it. So if I click it, instead of this list here, we ended up with 0, 60, 1, 148. So basically it's taken this list of values, it's iterated through them, and it's appended the index to each one. So that's perfect for something like table, because that's the values table is expecting. Tables to set the values in a table, you need to send a list of 2 values, one for which one it should be, and the second for what it's changed to. So, and that shows you on time. So even I could do stuff like this actually. Yeah, so if I move this now, there you go, we're editing. So yeah, this is kind of the back and forth user interface, working out programming stuff that kind of isn't very interesting, but is necessary to know how to do when you're trying to build better user interfaces. So we've kind of integrated this pitch probability table we can draw here, and it changes the multi-slider down there. Equally, if I edit, let's get this to somewhere where it'll stay in front of the window. If I do that maybe. Equally, hopefully, if I now edit values in here, you can see it's editing inside the table. So we've got back and forth user interface control, programming user interfaces. It's not thrilling, but damn it, you need to do it at the end of making a device. So yeah, any changes to the table should update our user interface controller, and any changes we make to the user interface control will update the table, which is good. And we'll set this to be continuous output as well, which should mean just as we drag the fader, it actually outputs continuously all the time. Nice. Okay, so that slight divergence was making another bit of the user interface a bit better. Put that into the UI. The other thing is I realized with this table object, if you actually edit the table internally by editing in here, which we're not going to do, it does actually bang and tell you, oh, something's changed. You might need to edit your user interface, which is what we've done here. The other time this table would change when we are not using the multi-slider we've actually designed here is when we recall a preset. So we made a patter storage and patter system here where we could preset the pitches and their probabilities, recall and store those presets in a really simple way just here. At the minute, if we change any of those, this will not update because we need to make sure this table dumps its values and sends them on to the multi-slider. Luckily, the patter storage object, if you ever recall a preset, it actually sends a message out the bottom called recall. So if I just press recall, it will say it has tried to recall a preset and what preset it tried to recall. So basically, quickly, what we just want to set up is whenever pad2storage tries to recall a preset, what you're going to do is bang the table to output its values and send them onto the multi-slider. So if we made a preset where, yeah, it looked like that, we'll store that as preset number 1. We'll then make a preset where the pitch probabilities look like this, store it as preset number 2, and as we switch between those presets, yeah, it's actually updating the user interface properly, showing us what's going on when we recall our pitch probability presets. And if we had this actually, let's go one further and check it's all working. So store as preset number 1, we've got a nice little design for what pitches are going to be played on the randomized pitch, and we've got that scale. Let's edit our scale. So instead we're doing some different values. We've got some totally different number of them even, and we're adding in, instead of octaves, we've got minor sevenths and minor thirds above and below. Get rid of the fourth, that's a fifth, that is a seventh above, and that should change the size of the table. And we'll want to now draw a different set of pitch probabilities. Why not? Let's just draw that, which is favouring randomized pitches playing the root note and then going down the scale. We can store that as preset number 2, and if we recall them between them, yeah, so it's working. We can see when we recall the different presets, the list of pitches changes and gets recalled. The number of pitches we can edit in the probability table changes and matches the number of pitches, and the values we stored for each one are correctly recalled, so that hopefully this preset thing is all totally working and the user interface is updating properly and we can edit it either way. So let's add this improved probability table view up here in our user interface now. So we can now resize it to whatever size we like, unlike that old I table. And why not, let's match our color scheme of black backgrounds and orange sliders. And I know you can also do this kind of grayed out thing that looks quite good. Where do you change it? You can make them have a little bar underneath of a certain probability. Like, God, it's somewhere in this, isn't it? Line thickness, no. Ghost bar line. What does this look like? Yeah, that's what we're looking for. Cool, so that looks a bit better to me. And it's all working when we do the changes. I think we probably just want to... the other thing you can do with user interfaces in Macs for live devices, you often see kind of matches a bit what's going on in some native Macs devices, is you have these objects called live.line, which just provides a kind of vertical line, simple user interface object you can use when you're designing your user interface is. So you can separate out your device a bit better. Maybe doing some stuff like this. Oh, we need to do loads of work to make this look better later on. But to some degree, we can start tidying up. Yeah, not the most exciting part of programming, but making not incredibly ugly user interface objects does make it feel nicer for you to use the user interface, and you might want to mess around with it more. And importantly, if you want to actually send it to anyone else for them to use, they probably want to have a user interface that isn't quite so horrible looking. Oh, apologies, seems to have something stuck in my throat. Can we tidy up you a bit as well? Ugly waveform displays. I think we can. You don't need to be so crazily big. Neither do you guys. Let's sort you guys out a bit. Similarly, we had our nice black and orange color scheme going on, so let's match up the waveform colors here quickly. No one needs this silly bar ruler here. We don't need to see what's going on with that. How do you turn up that ruler click? No. Showtime ruler. Cool, get rid of that. Vertical tick marks. No. Also, because it's an envelope, it's only unipolar going from 0 up to 1. So this kind of negative part of the waveform is kind of useless. So we're going to offset the waveform maybe like that. No, definitely not like that. Vertical offset, yes please. Oop, wrong way. Right way, and zoom. Zoom by 2, no. 0.5, the other way, yes. Cool, now we've got a better view of the envelope. I'm not sure I like that it's touching the top so much, but so you could kind of scale that a tiny bit. So instead, vertical zoom 0.6. Oh, that's a bit better. And the actual waveform itself, again, let's match up our colors and make it orange. No, that's the wrong one. Make the waveform orange. And we'll get rid of the time rulers because we don't need to see any of that guff, I don't think. Or grid lines. How do we get rid of grid lines? Who knows? Let's just get rid of the grid entirely just by turning its color to opaque. That'll do for now. And we've still got our recording bar that will show us our recording position. Bit too chunky for my liking. Thickness 50. That's kind of a bit more usable. And let's get a line over here, and we'll separate off at the very end of the chain. We'll have our volume, and like on some synths, you kind of get the voices kind of at the end. So why not? We'll chuck our max grains or a kind of amount of polyphony or a voice controller at the end there. That might kind of sit there nicely in the user interface. We probably want another control around here, around the waveforms. This is our live.comment sample. So let's chuck something there saying sample. I like some centered because it looks a bit better. And the one below is obviously, let's get rid of this guff. We're going to make this LFO a hell of a lot better in a minute, so let's just get rid of it for now. And that is our envelope, and we will need to do work on envelopes one day, making an actual better envelope display, but those can kind of live there and look a bit better. This is going to need to go somewhere over here near the start point, because effectively that transient control is setting the start point, and this LFO is controlling the start point. So those are going to do something over here at some point better by the end of this video. Pitch can kind of live back under here for now, and we want, get rid of these two help files. We'll chuck this pitch section over here, make it a bit nicer in a bit. I think we need a bit more width on this in case we draw a really long line of pitches. Drag these over here a bit. That's already a little bit less ugly, which is good. Tidying up user interfaces. Not the most exciting work, but does make things a hell of a lot more fun to use and send to people when they don't look so incredibly ugly. Some of these ones with the weird extra height, I don't like them when they're in line with the others because they look ugly as hell. So how about direction, pan, and pitch? You're going to have to live down here, out of the way of our nice other size dials. improve you guys. Oh, just making these all the same size, basically. Tidying up the boxes underneath them so they match as well. You need to be 40 actually, don't you? Cool. Cool. Change you to resize you as well. Duration, resize you. Yeah, got start duration. Volume on top for now. Direction, pan and pitch at the bottom. There'll be a scan control in there in a sec, so that'll won't look quite so disjointed. But at least that is a slightly improved user interface, looking a little bit better for now. One other thing we're going to do is this red playhead position. I actually figured out a way that hopefully we'll get onto next time of making a really nice display for all of these grains. Because although we've got a recording position, which makes sense, because we just turn recording on and it just records through the sample from start to end, and we want to show that. But you'll notice when it's ended recording, it just kind of sits there doing nothing. And if we went back to the start or before we triggered the recording, it's just sitting there in the way of the sample. To my mind, we only want this recording playhead to show up when we are recording, and when we're not recording, we want it to go the hell away. We don't need to see it. Get out of our business. So to do that, we need to do a little bit more editing over here. Yes, one other thing. If you make user interface objects in the presentation view, which can be handy because you just quickly want to create a few user interface objects and use them, but if you make them in the presentation view, they just get added to the patching view wherever you made them, so you can end up with a load of weird floating line and comment objects getting all in the way of your patching. So if you do that to quickly make a UI in the other view, you generally do need to come back into the patching view and tidy up what you've just done. Ooh. Oh, work. That kind of works. Anyway, that's a fair bit of user interface tidying, which should mean we're getting closer to the point we can use this device in our own projects without looking at it weirdly, going, oh, what the hell were all of those weird things floating around? I can't even remember why I put that device there, or that object there. When you look at a horrible user interface, it doesn't exactly make you want to play with it and use it. But what we were going to do is we were going to make this, another little handy tip in Max for Live you can do, which we're going to do with the LFO in a minute as well. You can make user interfaces, make objects in the user interface appear and disappear when you need them and when you don't need them. This recording position, we don't need to see it all the time. When we're not recording, I think we just don't want to see that red line at all. We don't want it in the way, especially when we design a better user interface to show back, to overlay on top of the sample and show us what grains are playing as well. It'll get busy having all the playheads for the 50 or whatever grains we've got, plus a recording playhead. So we'll make these user interface controls disappear when we don't need them. Luckily, before, when we were setting up something to make sure the user interface, you'll notice in the user interface from the last video, I think, when we're recording, the record button gets turned on, but when it stops recording and hits the end, we did a bit of programming here to correctly make the recording button turn off when we're no longer recording. So we just need to use something very similar. Some of the output of this code we've already made, luckily. So the button on the right bangs whenever we start recording, and the button on the left bangs whenever we stop recording. This even luckily works with looping. When looping's on, neither of these get banged until it actually stops. So if I turn off looping, for example, at the end here we should hit, and the left one should bang, telling us it's stopped, which at the minute just turns off this record button nicely by sending a set 0 message, sets its value to 0 without outputting poor effect. But what we want to add now is hiding or unhiding or changing the visibility of this user interface object. So in Max, there is a very old attribute in the appearance section in the inspector called hide on lock. Whenever you lock a patcher window, it will disappear. So this was even like back years ago, I think before we even had presentation view and stuff in Max patches, you'd end up with crazy cable spaghetti because you were trying to design a user interface in the same space you were patching, cables and objects flying everywhere, and you'd often use hide on lock, which I think was the key command, Command K or something, which so whenever you lock a patcher, just like that, an object would disappear. So I think if I Command K this object and then hide it, yes, so whenever I lock, it's disappearing. Don't really need to do that so much anymore because we've got a nice presentation view and we can design a presentation separate from our patching view. But you can still use that handy hide on lock attribute to hide certain objects quickly from the presentation view when you don't need them. Say this recording bar progress display. If we look in the inspector window, look at the hide on lock attribute, click the little attribute at the bottom of the inspector window, which shows us what the attribute name actually is. We can see this attribute name is actually got the name hidden. So if we send the word hidden, prepended by a 0 or a 1, to an object, it will hide it on lock. It will turn this attribute on and off. So I'm going to make a prepend hidden message. Should remember prepend just adds the word in front of it. So basically when I turn this toggle on or off, the object is hidden or unhidden. If we then line it up with these objects here, so whenever we turn record on, so we want this one, that gets banged whenever recording is stopped. Whenever a recording is stopped, we want to send the hidden command 1 to make it hidden. Whenever this one gets banged, yes, that gets banged whenever recording starts. So whenever recording starts, we want to turn hidden off. And so now if we simply connect, so the right outlet, remember, gets banged whenever something's recording. So that's when we actually want to turn the hidden behavior off, or we'd almost want a visible. The opposite would also be visible. You'd want to become visible when you're recording, go invisible when you're no longer recording. In this case, hidden. So whenever we are recording, we want it to stop being hidden, send a 0. Whenever we are recording, we want it to be visible, so we send a 1. So with this, and it's correctly just piped into this object, it allows to control this hidden property. If we actually lock the patcher, which is where it's affected, by default, its hidden thing is still on. But now if I click record, it's visible, but when it hits the end, it should go invisible. Boom. Yes, so now we've got that user interface control out the way and uncluttering the UI bit when we don't need to see it. If we turn on loop, I keep forgetting when you trigger loop, it actually triggers recording, which is a bit annoying. I'd like to be able to turn that kind of functionality off, but it will remain until we turn loop off, and if we stop recording, yeah. So whenever we turn recording on, it appears. Whenever we turn it off, it disappears. Perfect. So that's a little bit more user interface tidy up, getting us to a slightly better place. I think the other thing I did here was this user interface here was a bit unclear. Low, high, rise and fall, low, high. We have an idea what's going on because we're the ones who kind of programmed this, but if you gave that to someone else, they might not really have any idea what's going on. So just labeling a few of these things. I also remember now, of course, I made the label probabilities and the label pitches for these things, but didn't actually put them in the UI. So let's drag these up here. Pitches. And let's center that. Oh, wrong one. Need to reorganize this a lot, aren't we? Let's get rid of you. Pitches, and you can shrink down and go over here. You can come up here and go like that. Maybe something a bit like this instead. Is that centered? No, it's off center, so it looks a bit weird. There you go. Pitches and probabilities. Center that. that can get centered over the whole thing. And I don't like pitch quantize, pitch random. Randomization. Maybe a bit long, gets the point across. So this is a pitch randomization section, as the name suggests. Turning on diatonic mode starts randomizing the pitch diatonically based on the pitches and probabilities. Microtonal allows microtonal values, floating point values to be let through, otherwise it wipes them out. We do still somehow need to fit in that. I mean, 40 is kind of... Do you want to go any smaller than 40? Not sure we do. How could we squeeze this in here? No way you need to be that big. Let's... One, 2, 4... Squeeze in those UI controls ever closer. The other weird thing, when you put user interface controls side by side like this in Max, the text in comments doesn't quite line up with the text in user interface controls. Yeah, so you generally need to knock text up by 1 pixel to get it to sit in line. Weird things you learn and notice in Max after using it for way too long and trying to make slightly useful user interfaces. That kind of bundles in. The other stuff we're missing from the scale section quickly is a clear button for presets, because sometimes you just want to delete all the presets. To make that, all we need to do is make a new live.txt object. We'll give it the word clear in its user interface. Automation on off label. Space is clear as well. And it's not a toggle. Clearing is a one-time momentary action. And to clear something in pattern storage, you do just send it the message clear, as we can see in the help file, or by looking at its reference in the right-hand toolbar. But pattern storage does have an absolutely ridiculous amount of attributes and commands. I do happen to know it's clear, but yes, if we dive through here, clear, delete all presets. So we're just going to add that in there, add that to the UI. Storage window, we kind of never need to see out there. There's our 2 nice presets we've made that we can recall between. And I did a little bit of looking, and pat storage, generally in Maxland, pat storage relies on saving external preset files, text files, or JSON files, kind of a JavaScript way of storing data. So generally, when you're in normal Maxland, or you're working with very complex presets and you've got numerous sets of presets, maybe different preset files you want to load on the fly for different gigs, you can store them as text files and load between them. But generally for something relatively simple like this, and in Max for Live, rather than having the save mode, which tries to like save a JavaScript file by default to the hard drive, and all these other attributes and stuff which can try and load, make sure those preset files are loaded on opening the device. We want to get rid of this saving to text files on the hard drive stuff in Max for Live land for something this simple. If we just turn on the initial enable parameter, just like with other Max UI objects, it will save that value, or save a set of values to be loaded every time the device is dragged onto a track. So we're setting some initial values. So we can set a series of initial presets, for example, which anyone dropping the device on a track would get access to. So we may set up some basic major, minor, etc. scales that just get used all the time when we drop it on. But also turning on this initial enable parameter actually gets rid of the automatic file loading and automatic file saving, effectively disabling those attributes and setting them to 0 behind the scenes. So last time we made this device and made this pattern storage, when we closed the device, it automatically jumped up an alert window trying to like save a JSON file to the hard drive, and it's trying to load one when you open the device. So that just gets rid of that. So a lot of the time, if you're using pattern storage in Max for Live to build simple presetting systems, you can just turn on the initial enable value in its inspector, and that will get rid of pattern storage's, in this case, unwanted behavior, where it's trying to save files to disk. How can we tidy this up? Don't really need that, to be fair. Getting rid of spaghetti code. Yeah, today's definitely being a bit of a tidy up. Sorting out user interfaces session, but like I say, sometimes you just need to do it, unfortunately. It's not the most fun part of coding, but it does need to happen. And at the end of this, we will have a device that's a hell of a lot prettier than we can actually start sending to people and get them to test and use and find bugs for us, and also hopefully enjoy using it. Not just us messing around with my good friends Thumb Piano and Melodica. Other people might do some weird stuff with it and have suggestions and things they'd like added, which we can take into account and actually use and build. Another reason to make sure you don't have an ugly as hell user interface. Let's line up these again, chuck the clear button in. Can we shrink these even more? No, we can't. Clear, can we shrink you even more? We can just about get away with that. To be fair though, I think we can make that. Oh, that'll do for now. Screw it. And I did move these down to get them to line up nicely. You need to move them up by 1 pixel, and the text matches what's in live user interface objects. And it kind of looks ugly, but that'll do for now. That's the pitch section looking a bit better to my mind. We can turn on pitch randomization, turn on the microtonal thing, do presets, set pitches, set the probabilities. Audio analyzer, tiny bit of UI tidy up to get it to look a little bit better. We have a threshold. We actually want to be able to see that. That's kind of smoothing, I guess, or smooth. Let's go with smoothing. Put that in the user interface. This is a filter. Let's put that in the user interface. That is a gain control. Let's put that in the user interface. Let's get these somewhere useful so people can see them and know what's actually going on for when we start sending this to other people for them to have a play with. We're going to need to totally really space this thing out, I think. 150, I just don't like that number anyway. 180 seems a lot better for some reason. That should give us some space to knock these over a bit. What size are these? 40 is a better number for some reason for me. I don't like these not round numbers or weird numbered values. I don't know why. Resize these, nudge them up a bit, drag those over. You can go over here, you are gain, and that is a filter. That is some smoothing. Oh, that's not going to work. And that is a threshold. That's not going to work either. This is going to have to be 200 wide, isn't it? 200 wide. You come over here. You guys can come over 2 more. You guys can come over 2 more. You can go back this way. And that looks a lot better. And you can get dragged over there to match up. There we go. Audio analyzer section looking a lot better. Sample section looking nicer, and that disappearing will design a way better view to show the playing up to 50 grains at some point in the future, and that side looking a bit better. So UI tidied up, device looking a lot more usable, something we could actually send to people, have them play with without being embarrassed by how ugly the device looks. Hopefully they might actually want to play with it and give us some suggestions and feature requests and bug reports and stuff like that. Now let's actually do something useful after the one other thing I just remembered. The other thing is, when you're creating a Max for Live device, you've automatically got this bound, this limit in terms of height, because your device needs to appear in the device tray down here in Ableton. The other thing you have is a kind of a horizontal limit as well. So how much width of the device tray do you want your device to take up. You can have, obviously you can't go above this height thing, even if you redrag here. You can redrag MIDI clips and sample view and stuff up and down vertically in Ableton, changing the size of the bottom tray. You cannot change, but you can in a Max for Live device change the width of the device. So to do that, if we go to Max for Live device, look at the presentation view, go to the view, drop down set device width, we actually get a little line, which I can't access because I stupidly made it with the window shut. If you hit set device width, it should set the width of the device. Why did you not do that to me? Set device width, and it should set it to where you... What the hell's going on? Why aren't you working? View, set device width. Yeah, where have you gone? Oh, it's all the way over there. That makes no sense at all. Anyway, you can kind of resize the window, click set device width. So I think if I say clear device width, yeah, and if I say set device width, it should set it to where the window position currently is. If I then zoom out again, no, it's just setting it all the way over there. I have no idea why. Okay, so now that's given us a... Is there an object anywhere that's that wide? No. I don't know what this is about. Anyway, that allows us to set the horizontal width of the device. So that's our kind of viewport in the device tray. And we've now made a much better usable user interface that we're not ashamed to send to people to play with a device. I'm actually going to make these a little bit bigger so they properly break up the view. I'm going to make them 10 pixels or whatever that value is longer. Shift them up by 5 and they should nicely sit, breaking up all the individual elements of the user interface. And if we have a look in the device tray, we have a hell of a lot nicer looking device that we can drag onto tracks and use. Next up, some actual programming doing cool, useful stuff. Hopefully. Adding fun things, not just UI tidying up things. Something I added, which was really fun after having messed around with it a little bit yesterday when I added it. We built this whole audio analyzer thing, which was a good thing to do in the lesson to show people how to make an audio analyzer and was hopefully useful and interesting to know about. But we didn't really take full advantage of it, or at least not to my mind. We basically just added a way for this audio analyzer. After all this work designing an audio analyzer, all it does so far is when we turn on this transient button, it will automatically set the user interface, the start position, to be where it detects a transient while it's recording. You can see as I'm triggering transients, it's setting the start position of where we're starting to granulate to match where we are in the recording position in the sample. Cool, but we did kind of a lot of work. We did quite a lot of work just to get that happening. We should make more use of this audio analyzer, in my opinion, than just doing that kind of one job. So what I added was cool ways where we can have auto play and auto record functionality based on information we're getting from the audio analyzer. So from the audio analyzer, the main things of use to us, in this case anyway, we're not really going to do anything with the envelope itself, at least not for now, not that I can think of that'd actually be useful. But we can actually get, we've got an end, a start of a transient detector, and we've got an end of a transient detector. So maybe we actually want to do something with those and make them useful. So one thing I did was whenever a transient starts, we can start recording. Whenever it stops, we can stop the recording. So what that allows us to do is basically have a buffer that just records whenever a transient comes. We can kind of set the start position, the duration, some of the settings of the granular engine to just granularize around this fun starting area here. And whenever we actually trigger and record a new transient, well, it's similar to how we did it in this way, but slightly different. We're not moving the start point to the position in the buffer anymore for that kind of rolling buffer granularization. you can instead just focus on recording just little transients and messing around with them. It's quite fun and quite doable with a lot of the code we've already got. So if we go down to our audio analyzer section somewhere over here, let's get this a bit smaller. Audio analyzer land, we are getting transient on off. We're sending them already over this nice little analyzer send here. We have record on and off up here doing stuff. So we just want to set up a way where our receiving transient on or transient off turns on and off recording. So we can do auto recording, which kind of worked pretty well for me and I quite liked. So we're going to add that in now. We're going to make some space above this recording section because we're going to need to do some work above there. So we might as well tidy it up. Get all this stuff out the way, and let's just screw it. Let's just drag you way down here out the way for now. I haven't overlaid you over anything else, have I? No. I'll tidy up the patching view at some point. But for now, can't help it. In a tidying mood today. So we are sending information on when a transient happens and when a transient stops over this send channel called analyzer. One place where we'd already used it was over here to set the start point based on the record position. So one thing we could kind of do is just grab this send here, for example, in the root message, bring it over here, and we've also got a transient off that we're going to want to do something with, so we might as well get that. So now the analyzer is already turned on, I believe, and it's generating transients. Check. Check. Cool. So up here we should see, just because we've got this analyzer pre-created ahead of time, we can make transients, get the information out here. So we just need to wire this up properly to control our record functionality. So we need a prepend set up here because we just want to set the value of this record user interface button. We don't want to actually be turning it on or off here. We'll send an individual message down here to the object itself. Yes, I am incredibly anal about lining objects up. I don't know why. I'm finding it really hard to work when they're not organised properly. That's kind of a little bit better. Cool. That can actually kind of just be a trigger. 0, and it can get up here actually. Out the way. We'll clean up that wire at some point as well. Come on, why? Thank you. Auto. Aligning patch chords. God, when they were invented, it was such a good day in Max. Noise. So we're getting the transient on and the transient off. When we get I think with recording at least, with the playback I did some extra functionality stuff, but with the recording, you when you receive a transient, you want to start recording. That might be one bit of functionality. You might want it set up so just whenever you start recording, whenever you hear a transient, you start recording and you just record all the way from the start of the buffer to the end. No matter if there's no transient, you might just want to capture the whole length of this recording buffer from the time the transient happens to the end. You also might want to just be recording just short transients, maybe just into the very start of the buffer. So you might want the transient on to start recording, the transient off to also start recording. Someone just answered a question. Could you MIDI out so transients would trigger external factors? Yes, you can do a hell of a lot of audio analyzing. We could actually just grab this audio analyzer section of code and put it into its own device. You could actually just have a device, and I have made that for some visual VJing people's projects. You can make an audio analyzer device such as this, which analyzes transient on-offs and gives you a volume envelope. We could expand this and actually have it analysing the audio in the bass, mids and highs and sending those out. And it can send them out as MIDI, as OSC, and it can send them to external VJs and stuff. So if you wanted to make a device like that, you could effectively just copy this bit of audio analyzer code, which is kind of from here down. You could just chuck that into an individual device on Ableton, maybe onto a MIDI effect, set up what MIDI notes you wanted this to send out and stuff, and you could use that to trigger external synths or send to other people using Resolume and stuff like that, no problem at all. Just in our case, though, for this synth, yeah, we're just using it to trigger recording on and off and playback on and off. But with the recording, to dive back into what we were doing, let's make a live.menu object. So what I'm imagining is this is going to be like an auto record functionality. So let's call it auto record for now. So again, yeah, sometimes when I'm programming, I think of the user interface, so I make the user interface controls that I think I'm going to want to control, and then work the programming after that, because you kind of got an idea of what you want and then you just need to make it work. Sometimes the UI leads the programming rather than the programming leading the UI. So if auto recording functionality, sometimes you just want that off, because you just want to be manually controlling when things are recording and not recording. So we'll just set that to none as the first option. So when we select none in the drop down menu, we've just got off. The next thing I'd like the on, or the transient on, to turn recording on. And in that case, we'll just ignore the off. So whenever we receive a transient, starts recording, records all the way to the end of the sample. And then I'd also like another mode where we're using both the on and the off. So when we receive a transient on, we start recording. When we receive a transient off, we stop recording. So in that sense, we've kind of got a kind of multi options, multiple selectable options for our added recording functionality stuff. So now we've just got to line this up with the code itself. So when a transient, so what we're going to need is some gates. And by default, these gates could be off, I guess. We're just getting bangs, which is good. So these are going to go into some gates. And depending what we select in our drop-down menu, we want to turn these gates on or off to let the commands through to do things like turn recording on or off. So when this menu sends none, which is going to be, so there's 3 items in the menu. There's 0 or none on and on off, which is 0, 1 and 1. 0, 1 and 2. See, if we select items in the UI menu, it sends out a 0, 1 or 2. We can run that into a select object, which just selects the numbers 0, 1 or 2. So just to give you that example, that now means in Max, whenever we select a different object from the user interface, we get a bang out of a different output, like that. Whenever we select none, we want to close both of these gates. We want everything to stop happening. Close both gates, don't allow any information from the transient detector to happen. So when we select none, both of these gates should be closed. When we select 1, which opens up the transient on to control recording, we want the first gate, which allows the transient on through, to open. We want the second gate, which controls the transient off, to close. So if I select item 1 from the menu, that gate should be open, this gate should be closed. Correct. And finally, when we select option 3 in the drop-down menu, which allows both the on and off to control recording on and off, then we actually want that gate to open up and that gate to open up. And if I select that in the menu, we should see, yes, that gate is open and that gate is open. So now this user interface menu properly controls these gates to allow transient on and off to come through. The next thing is obviously we want to actually control the recording on and off. And to do that, this side transient on is always going to start recording. This side on the left is always going to stop recording. And what we want to happen is when you need to just make a trigger object to, so yeah, again, using triggers all the time, all over max patches, because it allows you to control the flow of information and when data moves where. Why aren't you lined up? That is better. So first you are actually, ooh, God, it's already detecting transients and starting recording. So first thing you do is actually turn recording on or off by sending your value down to the recorder object, either a 0 or a 1. Next thing you do is actually update the UI to show us when you're recording, which in turn, due to this nice thing here, will actually update that as well. Let's put you guys into the user interface and test out your functionality. So this auto record stuff, I think we're going to want somewhere over here. Trying to remember how I built the other user interface so we can match it up nicely. I think I made this a bit bigger. We need to do that. We'll do that in a sec. Auto record. Too long. Just going to call you auto. And little user interface control that allows us to set that. What if we make you like 80 pixels wide? Yes. You can be like that wide. Does that allow all the objects to display when you select them in the menu? Yeah, one thing with the menu when you're creating user interface, make sure when people select different items in the user interface, they can see all of them displayed in the menu, which seems to be working there. So that's our auto. Oh no, I've just put it underneath the play. Unless it's called grains. I don't like that. Let's just call it play. That's clearer. Play. So now I've just got play and record buttons. Nice and clear for everyone. That's record and that's recording off. And recording on. Probably need to resize these at some point because that is giant, isn't it? And for some reason, all the user interface objects like these, they always are just 5 pixels. They go halfway into another block, so if we make you 35, you should... What? 25, yeah? Nice, that lines up a bit better with other user interface objects. Change, what the hell? 80 point, God knows what happened there. Make you line up. So yes, I did actually just add this to totally the wrong button. This is actually the auto record functionality. And again, these don't line up properly. If you look, you need to up it by 1 pixel, just so it sits nice. Matches the other bits of user interface. Nice, we have auto recording. Oh God, it's already working, isn't it? And we're going to sort this out in a sec, because that is all kinds of wrong. Cool. Check. Hello? Yeah, functionality working. So you should see we've added now an auto recording functionality where whenever a transient is detected, because my voice goes loud enough, we start recording. And due to the setting currently being on and off, I can continue recording for as long as I need, and it doesn't stop recording until my voice again drops below the threshold with the smoothing applied. So I can talk like this, and it's actually going to start recording and recall all the way into the buffer, and then when I stop, it stops recording into the buffer. So this allows some great auto granularizing of whatever's coming in another way. If we just turn on none, then yeah, I can do what I like. trigger transients and no recording is happening. If I turn on just on, whenever a transient is detected, it should turn on, but it should record all the way to the end of the buffer. Check. Should go all the way to the end of the buffer, even though there's been an end. Yes. And just like we saw before, on and off allows me to make a transient, and then when I stop talking, or whenever it dips below the threshold due to this falling thing, if you, for instance, lowered this a load, so we're having a very quick attack and fall, we can actually get incredibly small little bits of recording, which might be a bit too much, which is why we've got a nice full parameter. Check, check, which allows us to kind of hold that a bit. Check. One thing, however, yeah, so that's cool, having auto-record stuff. We're going to fix something with that in a bit. The other thing we might want to do, and I have added before, is autoplay functionality. I'll turn off this auto-recording for now. So one thing you can do with that is, for instance, you can have automatic playback. So whenever it picks up you playing a transient, it starts to kind of maybe harmonize around these pitches around you and do some little cool playback tricks. Or the other thing I added, which I think is really nice actually, is kind of almost a side chaining granular effect. So what I did was made it so you could actually, so similar to this record thing where we've got auto recording turned off just on the on transient or on and off based on the transients, you can also add a kind of side chained or inverse, you can add the functionality inverse of that, where whenever we receive a transient on, it actually stops granulating, to allow the grains, the note you play to come through and the grains turn off. And then whenever you actually stop playing a note or detect a transient off, it will then actually turn the granulating on. So it's almost kind of like a side chain. You're kind of building this side chain where the synth stops playing when you play or send something into the mic, and it starts playing when you turn off. So whenever you're not playing a note, you get this kind of background granulating, and whenever you play something loud, the granulating fades off, allowing you to speak through or play through it. So let's kind of add that functionality. So we've kind of got a working version nearly entirely built up here already, so we can basically just copy the majority of this kind of code. Actually pretty much all of that we can copy. We're going to need to chuck this down in the play section, which is over here somewhere. Might need to make some more space at some point. For now, I'll just chuck it somewhere around here. Here's our play control. Let's get it involved with that. We need to turn the metronome on when we want to play. We need to set the command as well. So, boom. That is already automatic grain playback on and off. Now's the first time in the tutorial where we might actually play something, and we will see how poorly my computer is dealing with what's going on if it just completely fails to even play anything. But I think if we just copied that exact same bit of code, we have lined up and connected it to the right inputs. So on play we are instead controlling the metronome to turn on or off and this play control. And if I actually enable it and have a look in the user interface, we should see I can trigger playback. Yellow, check, check, check. Might want to do, and I have added before. Yellow, play, boom. Yeah, so the duration there was quite long. So whenever I stopped talking, it did actually take a while to fade out. But if we kind of drag down that duration a bit and I re-enable this auto playing, so automatically triggering on to play when I speak and triggering off to play when I stop, we'll kind of get this automatic granularizing of whenever I speak. And we could also set up the auto buffer recording, because that would actually make it record what I've just said when I say it, and automatically play it back as well. Tweak the granular settings a bit so we get a bit of volume randomization, bit of pan volume automation. Start position we'll keep at the start because that's where we're recording, but we'll add a tiny bit of variation. Duration will shrink down. And why the hell not? Let's add some diatonic pitch randomization as well. So now if I turn on this autoplay behavior, whenever I talk and it detects a transient, it'll start recording into the buffer, start granularizing it, and whenever I stop, we should stop recording and stop granularizing. Yellow.
Transient.
We're also catching just some of the previous things recorded into the buffer, you can see. Hi. Check, 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 check. Hello. And it's automatically harmonizing and pitching around what I'm saying as well. So you can kind of automatically get this cool little granular stuff. And it only lasts for as long as I'm talking. Yellow, check, check, check. Check, check, check. Nice. And you can do that with the instruments as well, of course. We might want to add something in that automatically kind of deletes the buffer each time if we want a totally clean new buffer for every time we record. Because we're definitely getting some material from the old buffers. Boom. Auto recording and playing. Next thing I want to get working though is that kind of side-chained playing idea I had working. So we can also, as well as just actually when we talk it starts granulating and then it turns off when we stop, we want to inverse that. So we want to almost add a sidechain granularization, sidechain granulating. Things need to get a little bit more complicated for that to happen, but not too much more complicated. Again, let's kind of work with this by turning on the working out the user interface first, and then we'll add the programming underneath when we know exactly what we're doing. So I think we're going to want a auto playing off, being triggered by the transient on, being triggered by the transient on and off, and then we're going to want the inverse of that. And again, unfortunately, due to the size limitation in our UI, we want to keep that kind of writing nice and small so you can select it and see the answers in the UI when they're selected. So, oh god, I just turned that on, didn't I? So we're going to want to have some kind of, I'm going to use a mathematical inverse kind of thing, which is generally done by using an exclamation mark in front of something. So you can kind of do, you can invert a mathematical function by adding a, you can't really do an invert plus, invert divide, yeah. So generally, yeah, in some math things, formulas and equations and expressions, you use an exclamation mark in front to signify that it's been inverted or flipped. So I'm going to use those in our names. So I'm also going to add an inverted on and an inverted on plus off. So now we've got 5 options. So we're going to need to increase our select to include 5 options. So the first 3 are going to remain as is. We're going to need some extras. When we select the inverted, or when we select the same on, so the inverted on, when we select that, we're going to want, well actually we're going to want the same thing as our normal on, aren't we? Yeah. We're going to want that on, the transient on, to be allowed to pass through, and we're going to want the transient off to be closed. Select that, that should close. That should be on. Excuse me, being interrupted by the granulator. And when we have on and off selected, we are actually going to want the same thing, which is fine. So that's kind of exactly matching these two. You could actually just wired that up to there, wired that one up to there. But we're going to need some other programming. So at the minute, the transient on is kind of hard-coded to just trigger a 1 to make something record. The transient off is kind of hard-coded to trigger a 0 to make something stop. But we're going to want to kind of be able to switch those on the fly. So instead of a trigger object, we are going to make a little bit of space, and we're going to turn this into an integer object, which by default will store the value 1, and this is an integer object which by default will store the value 0. So by default, if we just bang them, they are going to send a 1 and 0 as before, but we can send an integer into the control here to actually change what number it is. So we're going to slightly expand these trigger objects underneath our select object, allowing us some more controls. And we actually just want 2 different things effectively. So whenever each of these happens, as well as changing the gate values, we actually also want to bang first. And the bang is going to trigger either these to be set this way. So this is normal non-inverted fate behavior. When we bang a normal non-inverted option, we want to set transient on to send the command 1, or on, in this case to do play, and transient off to send a 0. So the first 3 items, well effectively the first items are none, so you don't want that to do anything to do with that, but, well, anyway. The first 2 items after none in the menu are non-inverted, so we want the normal behavior of on, turning play on, off, turning play off. So when these 2 items get selected, they bang and set these values to be 1 and 0. When an inverted function happens, we want to invert that behavior, and the on would actually be a 0. So now this is going to be triggered to set this to 0. So transient on would actually turn playback off, transient off would actually turn playback on. And that's the last 2 menu items there. So you actually end up with something a little bit like that, I think, with our extra menu items and our extra granulating business. And you know what I think we're really going to need is an auto clear for clearing this buffer. And that needs to be linked to the record, not the playback. To clear a buffer, I'm pretty sure you literally just send it the message clear. Yes, you just literally send it the word clear. So the other auto thing we're going to want is an auto clear. Let's see if I can get this to work as easy as I think I can. I'm going to make a live.txt. Delete the hell out of this extra load of package crap. I'm going to call it clear. Oh, what the hell happened there? Clear off. I mean, no, you're just clear either way. Why have I just written the word clear 4 times? I could just copy pasted it. Clear, 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 clear. Yes, yes, yes. And you are just a momentary button. You're not a toggle. Can't happen twice. And whenever you get the clear message, you actually just need to send the word clear to the buffer. We'll just even do it as ugly as that for now. Put that in the user interface. Oh no, God, clear should be a toggle. What am I thinking? Don't just want to be able to hit a button. That's useless. We want to have transients triggering this stuff. This needs to be more confusing than I somehow thought it was. That is a control. Clear is now a gate, and it either opens or closes. When clear is turned on, the gate is open, which would allow messages coming in here to actually do stuff. So what we want to happen is when a transient turns on, I guess, we'd want it to first clear the buffer and then start recording. We want to hard program it so that definitely happens the right way round. I mean, those are just bangs actually, aren't they? In theory, maybe what's going to happen now is when clear is turned on, first we're going to clear out the buffer and then we'd start recording into it. Which should mean we don't end up playing over a load of guff that's left in the buffer from what we were doing before. So we also now have auto clear behavior on the record section. If I turn on auto recording functionality, and why the hell not, let's turn on our new and, well, the same as last time, auto play functionality, and let's see if this works. So if I do something in the buffer, and it should now automatically clear that last buffer rather than playing it, so we don't end up talking over the same thing. So let me try some thumb piano. When I play some thumb piano above the threshold, we should clear the buffer, so there's none of this talking left. We should start recording and record in the thumb piano, and then we should also start playing it back at the same time. Cool. Yeah, so we've kind of got this cool auto behavior. And I'm going to invert the play functionality now. So what should happen is when a loud note happens, it turns off, but it still gets recorded. But then when we stop talking, it actually starts playing back. Yellow. Damn it, that didn't work at all. Why are you not working? Yellow. This looks like it's working. This is kind of like a side-chained granularizer, I guess, where it turns off when you stop talking. Sorry, I mean it turns on when you stop talking. I think that one was particularly nice, to be fair. Auto, dub, chord, recording, texture, business. Seems to be working pretty well as well. God damn, the love of Granular is real. So we've now got auto recording, auto playback, auto clearing of buffer, all related on the transient recording. So that's kind of doing a lot more now. All that work we did programming the audio analyzer seems a bit more worth it now. With all the cool stuff we've got going on. Automatic harmonizing of any input. Something I enjoy and think's working pretty damn well. So happy about that. One thing I did notice that I had improved on in the thing I worked on kind of over the last few days, tidying it up in my own time, we previously to set what you'd consider on most granular synths to be a density control. So whenever we trigger playback, we have this tiny little piddly user interface control that's kind of tiny and was sitting under here and not looking very inviting or like you'd want to play with it. This was setting how fast a metronome would try to trigger grains. Just here. So generally the playback mechanism for this granular synth is a metronome being turned on or off by this button, or by now our cool auto playback system, and it was just triggered metronomically, like a metronome, just very rigidly at the time specified by this little live num box. Generally on a granular synth or granular effect you might kind of call that density, because it is also affected by the duration, because the duration defines how long one of these 25 polyphonic voices is in use for before it's freed up. So if you have very long durations, even turning this down, because voice stealing is turned off in the kind of polyphonic synth terminology, the duration will affect how dense a grain cloud sounds, but as will definitely this control here, which is effectively the density, which is, again, just I think we made a while ago as a tiny little number box, and it was sitting under here, not looking great, not looking very inviting. So let's actually switch that to be something a bit better. We are going to make a live.dial. We are going to call it density. Yeah. Like that. Boom. And we do want it in time. What am I doing? None of those. Unit style. Come on, brain. And what did we have? Probably from like 1 to every 5 seconds. That makes sense to me. So 1 is obviously it's going to try and play a grain every millisecond, so 1,000 times a second. So you'd nowhere near get that with this number of voices. But if you had a super powerful computer with a ridiculous CPU and stuff, maybe you could up the number of grains to 1,000 and try and play 1,000 grains at a time. It probably... Who knows what would happen? You'd need a pretty powerful CPU to deal with that with this max thing anyway, probably. But why not? We'll allow you to try it out anyway. But voice stealing is disabled on this poly, so whenever it's busy playing a note, you won't be able to play another note until one becomes free. So there's kind of some limiting to how dense you can get things. But we can get rid of this ugly control and instead put in our much improved density control here, which I think looks a lot nicer, especially if I chuck it in the UI. And I think by default we were saying we were trying to make a grain 4 times a second. That would be every 250 milliseconds. Ooh, and we need to add a bit of logarithm exponent to get a better logarithmic curve, as we've done before. Again, you want quite a bit of movement in this 1 to... That's not even enough, actually. I reckon we want to go even more extreme. We want to have quite a lot of option to fiddle in those low millisecond values up to about a second. Once we hit a second, well, you know, you don't really... You can be quite loose up here, or you can type it in, but you want to be able to nicely control it here and change in these really low millisecond values. That's why we add exponents to controls to get a better range of values on the dial. So halfway through the dial is about a second. And we've got all that nice range on the dial there to go into these low millisecond values. When we go above about halfway, we go from about 1.5 seconds all the way up to 5. That's fine. That range is fine. It'll default to about 250. And now in the user interface, we can have a much nicer density control, rather than that tiny little live numbox thing we had, which just was not doing it for me at all. The other thing is, at the minute, the grains are still being triggered very rigidly. They're being triggered incredibly metronomically, rigidly. Kind of cool, but, you know, again, we're working in granular land, we're doing big grain clouds, we've got randomization on every parameter possible. We also want some randomization on our triggering of grains. So we're going to do that by adding a extra option called randomize. So like under nearly all these user interface controls, we've got the option to dial in some randomization. Under density, we don't want a kind of percentage of randomization, I think. Maybe we do. We could add a kind of jitter function. And percentage of jitter that it's going to move either side. No, for now we'll do something a bit simpler. Maybe we'll go crazy and add in different types of randomized grain triggering. But for now, we're just going to have one. We're going to call it... Jesus, I can't type today. I think it's because this microphone is in the way of my keyboard and I keep... And the few times I need to look at the keyboard, I can't see it. We've got a new control. It's called random. It goes on or off. When it goes on, we want our metronome not just to bang metronomically. We want to have a bit of maths underneath. So you might remember, not that we've looked in there for a few videos now, because we kind of programmed it so well we haven't needed to really go back inside here much. But a lot of the times here, when we're dealing with randomization and randomizing parameters, we were dealing with using a random object, which generates a random number, and we can do some maths on that to scale it or mix it in using amplitude control and adding it to other values and stuff like that. So in this case, we are again going to use the random object, and we're going to do a kind of random coin toss control. So when we turn random on, every time the metronome hits, we want it to bang this random object. And we want to just have a coin toss. So just like we're flipping a coin, heads or tails in the air. And do I need to type 1? Is that going to work? No, because you need to be 1 above your max value, so it needs to be 2, and that's just going to hit 0 or 1. So this is now like a coin toss, kind of random. There's only 2 possible values, and those values are 0 or 1. Whenever we bang it in the top, it's effectively the computer's just kind of flicking a coin in the air, and it's telling us whether it lands heads or tails. Just like that. And what we want to do is we want to say, are you equal to 1? So if the coin lands, let's say heads is 1 and tails is 0, that's the way I kind of think of it in my head. Now, and if we then do a select 1, in fact, we can just do a select 1. We don't even need the equals to 0. What am I thinking of? So random is going to output either 0 or 1, and we're selecting all the 1s, so effectively all the head when the coin lands heads up. And now we can bang in the top, and we only get a bang out the bottom when the coin landed heads up. So now we can add in extra bit of code here. Let's keep you there, keep you there. Get this metronome up here a little bit. Sort you out a bit. Metronome turned on or off by play, controlled by the density control, just as expected, but we also need a gate now. The gate has 2 outputs, and output 1 is open by default, and the metronome gets passed through that gate. By default, it just goes straight to the play object and triggers the message play. Just as expected, that is fine. Let's get our random control in here as well, so it's actually controlling the gate. You need to add 1, because if you remember, if we send a 0 to a gate, so by default a toggle box or a num box just outputs 1 or 0, but if you send a 0 to a gate, it actually closes both outlets, so we actually just want to switch between gate outlets 1 and 2, so if we turn on, the data now gets sent down here, or the bangs from the metronome. If we turn it off, they get sent down here. Perfect. Put you in the user interface by adding it to presentation, and so by default with random off, metronome goes straight through to the play just like before, but with random mode turned on, instead we actually get it to hit this coin toss logic, and the coin toss logic should then randomize how often the note is played a bit. So instead of this metronome just hard triggering the play metronomically every time, we've got a slight bit of coin toss logic in here now. So the playback is more randomized. Every time a metronome is triggered, it kind of randomly decides whether or not to play it. So it'll kind of add a less metronomic playback of metronome of grains, and there'll be a kind of bit of coin toss, so just adding a bit more randomization and variation, which in Granular is exactly what we're looking for. So we've now also got random control, a better density dial with randomization of the grain playback. And I'll just match that up here. We're going to want to add a scan control with an LFO to start. Ooh, it'll kind of be there somewhere. We've still got this transient, this kind of, I'm going to relabel this auto. We've kind of got this auto start position control from our previous work building the start position, so we could automatically have transient set the start time. Did I disable that? Is that why it's no longer working? I have no idea. Anyway, the audio analyzer can still set the start point of this start dial. And we have an LFO which can move the start position. They can kind of sit there for now. We have a much improved playback and record section here. And we have better density and randomization of when notes are triggered. So just as an example that that's working, if we added a bang after this play object with random off, I'll turn this down a bit so we can see the LED a bit better. We can see a very metronomic triggering of a grain. As we turn random on, we can see there's occasionally some skips and stops and starts as the coin toss logic is controlling when grains are played. So we've now got a way to randomize the playback of the grains a little bit as well, which is always nice with granular stuff. One other thing I added which to this autoplay and auto recording functionality, which is something I kind of spotted on this module called the Instruo Arbor. The module's called Arbor by a company called Instruo. So they've got this auto recording functionality, which is partly something that triggered me to kind of think about adding it myself. When we just hard map the transient on or off to the playback on or off, or the recording on or off, we can have a fiddle with the threshold and the smoothing to somewhat control how long it takes for a off to trigger. You can change the full and the threshold and the rise to kind of control when transient on and transient offs are triggered by the audio analyzer. But if we want a bit more control, over the recording, one thing you really want to be able to do is have a kind of hold function. So for instance, you have a hold value you can specify in milliseconds, and that means whenever you turn, say, auto recording on, we're not going to allow it to record again until it's recorded for at least a specific amount of time. Because otherwise you can end up just recording these really tiny, if you're doing something very percussive, maybe some kind of drum stuff, you might end up with the on and off, the recording on and off being triggered way too often, more regularly than you like. You might just say, I don't want to keep recording and writing and overwriting the buffer unless it's recorded for at least 2 or 3 seconds. So one thing you can do to address that is adding in a hold function, which doesn't allow values to pass through unless there hasn't been another value, so it won't allow another value to pass through for, say, another half a second or a second. So we can do that by adding in some cool hold functionality, mirroring what we have on the Instruo Arbor. And we are going to do that by, let's add into the record first, because that was a little bit simpler. So we are getting the numbers through here, and then they're hitting here. So kind of in here somewhere in this bit of code, we want to add some kind of holding functionality where we can set a hold value, and that will stop a value passing through for a certain amount of time. So you're going to kind of need to have some kind of timer. So when one of these triggers, a timer starts, and it starts counting, and then when another one tries to happen, the timer would tell you how long it's been since the last auto record was triggered, or the last transient happened. And then we could say, set a value and say, well, if you're the second value that's occurred within half second, we're just going to ignore you. We don't want you to happen. That's too soon. If you're after half a second or after a second or whatever we set, you could then allow it to pass through. So let's program some hold functionality by using a timer object. So this is a nice object in Max, which allows you to just report timing intervals quickly. In the, let's see, so I think you start timing something by sending it a bang in this outlet. In the left-hand inlet, you can tell it to start counting. Whenever we hit the right outlet, it will tell us how long it's been since we first clicked that left inlet. Like 10 seconds now. Keeps just going up and up until we hit the left inlet again, and that resets the counter. So the timer object allows you to do things like time how long it's been since an action last happened. So you can make more complex audio analyzers, for example, for mapping to visuals or MIDI or generating MIDI notes and all kinds of things. You can make more complex audio analyzers where you might detect how long it's been since the last transient time, or you can, for example, time the lengths of transients and get an average of transient times by timing when a transient on happens and when a transient off happens. You could then average that over a period of time, and that would kind of give you some information on whether someone was potentially playing longer notes, or they were playing an instrument that generally has a longer, bigger body or a resonance time kind of thing. Or if they were playing very percussive material, you'd expect transient on-offs to be quite short, providing you'd set your sliding or smoothing to match that. So yeah, you can do more complex audio analyzing by doing things like timing differences between transient ons and offs and stuff like that. So thinking about the code, we have a timer. Good. Whenever something happens, we want to start triggering the timer to count. So you can imagine this is going to be when something like recording happens. We're going to start this, but for now we'll just program it over here using a bang just to allow us to kind of run through the code. separately and check its functionality before we program it into the actual recording functionality. Hold time. We are going to want to have a user interface object that allows us to set the hold time. That's going to need to be a live.numbox. Ooh. Tidy this up a bit. It's going to need to be in milliseconds. Initial hold time for recording. Don't keep triggering recording unless you've recorded for at least a second. 2 seconds, why not? Range enum between 0 hold time, so basically hold is off, up to, 5 seconds. 5,000 milliseconds is currently the max length of our buffer, so why not? Live.numbox. Let's make a control. Oh god, sorry. Live.comment. Let's make a comment called hold. That's our user interface control for our hold time. Timer, again, like I say, if you bang the left inlet, it starts counting or resets the counter to 0. Every time you hit the right outlet, it tells you how long it's been since you started counting. So at the bottom, we get a time in milliseconds, floating milliseconds values. We can set the hold time, and by default, it will be 0. So is the number greater than 0? Well, the number's always going to be greater than 0 because some time has elapsed. Even if it's very, very small on computer time, that's something they can count. So whenever this is set to 0, in theory, the timer will do nothing. It will be bypassed. Rather than having a hold on and off and then a time, we can actually just use the hold time itself to turn this functionality on or off, because that'll set to 0. So anything hitting here now should be above 0. Well, it will definitely. I can tell you that for a fact. But yes, if we set this to, say, a larger number, such as 2 seconds, 2,000 milliseconds, if I press on to start timing and then off within 2 seconds, it will not trigger a bang until 2 seconds has passed. So if I click that and then click here, I tell a lie, it's just going to work instantly. Why are you working? Bang. Ah, because you're getting a 0. So if we say select 1 to say only select the yeses. So are you above 0? Give me the answer when you're above 0. Within, let's make it more obvious, 5 seconds, don't allow another bang to pass. So we've kind of set a timer here where a message is not going to be allowed to pass through until 5 seconds has elapsed. So I'll start the countdown, keep triggering, nothing's allowed to pass through. We should hit 5 seconds soon. Bang, and now you're allowed to pass through continuously. You can see that with the numbers here as well, if I demonstrate that. But this is a way to set up something that kind of holds a value or stops values passing through until a certain period where you can set. So you can trigger, nowhere near 5 seconds, but when we get over 5 seconds, the values are going to be allowed to pass through because the initial time limit has been gone past, been eclipsed, whatever the terminology you want to use. So using this functionality, we can add in this hold behavior to stop recording happening so regularly, so we make sure when we're auto-recording or auto-playing, we are getting a decent amount of recorded material into the buffer before you start doing stuff again. So we do want to be able to set it here like we have, selecting 1 whenever it's happened. Once it's happened, so one thing we need to do is we need to actually get our useful value. So at the minute we're just sending through a bang, but if you imagine we were sending through any number, you could even do this with a word or anything really. You could be only passing through sentences when a certain amount of time has elapsed if you wanted to. So we are going to send our message down here and store it. For now we'll store it in a ZLreg, which is just a way of storing a list. To make this kind of less obvious, we could actually just do something useful. So by default we're storing a 0. We're storing an integer down here. We are going to pass through an integer, which is what we're currently doing to make this type appropriate. But yeah, you could use lists and zlreg to be able to store any information, including sentences, integers, floating points, or bangs. But we'll just do it this way because that's what we're currently using, just to make it clear to other people what's going on, hopefully. So whenever something in here happens, we send through that information to be stored down here, but not output. It only gets allowed to be output after our 5 seconds has elapsed. So we can set this, we can toggle this, and it's only when 5 seconds has passed, the numbers should appear at the bottom. Come on, numbers. This is the wrong way round, isn't it? Is that why? I bet it's why. Let's see this example work properly so I don't look like a fool. Cool, we can trigger our timer to count. I can fiddle with numbers here. Nothing will be output until 5 seconds has passed. And now it gets passed out the bottom, passed on cleanly. So we kind of want that functionality to happen. So we can trigger, say, something's happened. And now don't let anything pass through until this hold time has passed. Yeah, now it's passing. But obviously we want to trigger this timer to start when something happens. We could trigger it when this happens, but that's going to cause an issue because every time we send this number, it's triggering it to start. Every time, you can see here, it's just glitching out. What we actually want to do is add a bit more of a complex flow to this. It's only when a number actually gets passed on at the very bottom of this. So after the timer, when something actually clears this hold time function, we want it to actually restart the timer and start counting again. So when a value is allowed to pass through the timer, because it's gone over the hold time, if a value comes through after that hold time, we start counting again and limiting stuff. In this example, that's how we want it to function. You could make different kinds of hold functions where you're doing it, separating this value. You know, you might want another value kind of side chaining or stopping values passing through for a certain amount of time to bring back that kind of audio side chaining terminology into this analogy. But in this example anyway, if I send through a number here, for example, it's been over 5 seconds, so it should immediately pass through here. It should reset the timer and be output out the bottom. But now we're counting, nothing's going to pass through until we hit 5. Bang, something got allowed to pass through, but then we froze again. Hit 5 and it should pass through one figure, yes. Bang, something was allowed to pass through. Hit 5, one will be allowed to go through. Bang. So basically we've set up this hold function where only something can pass through every 5 seconds. Everything between those 5 seconds is ignored until the hold time has elapsed, and then we're allowed to pass through another message. So we've kind of set this limiting functionality where messages can only pass through, in this example, every 5 seconds. We could expand this code by passing through L, which is a short code for list, which basically means anything. Could be words, sentences, floating point numbers, anything at all. zlreg is an object which stores lists. Not that useful, I know. There should kind of be a list object like there is an I in a float object. I think technically you can use a list. Is there a list? I mean, technically there's a list object, but I think it's just a repackaging of the pack object. And I'm not really sure about it myself. So zlreg allows you to store a list by sending a list into its right inlet, outputs it when there's a message bang, just like the integer or float object we have used many other times in this work. So what we have here now is a fancy bit of code that allows us to limit the throughput of messages by setting a hold time. Nice. If we now add that into our code up here somewhere, what I'm imagining is we effectively want to limit the throughput of values somewhere around here. I think we want recording Do we want to limit them both at the same time? Or do we want to just limit... Do we just want to limit the start of the recording? Or do we want to limit the off of the recording as well? Because otherwise we might actually need an individual hold time for the starts and the ends. I think at least the way it works on the module, so that's what I'm going to copy for now, is we only actually hold and time limit the messages to start recording, and off a stop recording message can actually happen at any time. So that just actually gets passed straight down there, because that can happen at any time. We don't want to be limiting when off messages can happen, but we do limit when record start messages can happen. And we now have a little hold control, which is stopping it continually jerking the record functionality on and off too often. We're also going to need to clean up that because we don't want it continually clearing the buffer too often. God, you could actually pass through the clear and the messages through the same thing, but that's going to be ugly as hell. Okay, quick bit of extra tidy up. If we set the hold time on the recording to auto control the transient on recording, it can always turn off, but we also want to have that linked to the clear recording because we don't want it to suddenly keep clearing the buffer when we set a hold time. So I think we're going to add this as well, and we're going to limit. We're actually going to sort this out a bit. We're going to get you over here, separate out transient on for itself. Actually, no, we do need to be able to hard say we always want transient on to first clear the buffer before it starts recording. Otherwise, we're going to end up with potentially ugly things where it starts to record, clears the buffer halfway through, and does some weird stuff. So we do actually want that one transient on message to use a trigger object to control the flow of information, to control the clear buffer to potentially happen first. It's going to get a bang message and pass it through. Because we expanded this to use pass on a list and store a ZL reg. This will work. The same code will work with any message: integers, floats, lists, sentences, symbols, whatever. So luckily, it will actually work with this bang. Not previously, before we changed that I and that integer, it wouldn't have worked with the bang because it would have. Well, it technically would have anyway. But the point is, the way it works now is a little bit better because it can work with any bit of information. So at the same time, in the record section, when we change the hold time, we can make sure it doesn't clear the buffer too regularly, and it only starts recording at those times as well, if I'm correct. Which I think I am. So we're going to add this hold time up here into the record section. Somehow, geez, it's going to be ugly. Auto clear like there, maybe. You have no business being that tall. And chuck you in here. Chuck that in there. Obviously we can see this isn't working. We're going to need to squidge you up a bit. Damn, this is becoming a bit overly condensed. We might need to shrink down these play and record buttons even further. Oh, but I like them being kind of larger than the other things. It makes sense. You want to show off your play and record buttons as they are the big boys who are doing a lot of the work in the user interface, and you want them to be quite visible. We'll deal with it. We'll clean it up some point. So you have auto playback behavior, and you have auto clear behavior, and you have a hold value which you can change on the recording to make sure it doesn't overwrite Oh, Jesus, that was an accidental move of the user interface. Totally messed up what was going on there. And now Max has froze. Oh, a great time to be alive. Go back a few steps. That was when ugliness happened. Yeah. Cool, so now we've added a hold function to our auto recording, so we aren't recording or clearing the buffer too regularly, which is something I noticed when we briefly tried playing with it earlier. We've got a much better density control with random playback control, a bit better. User interface is looking a hell of a lot better in Ableton. Nice. And I think we are now approaching... God, that is stupid. Gonna have to sort this out at some point. Definitely. We'll leave it there for now. So, as usual with Max, it takes more time than you think to do some jobs. So yesterday, as I mentioned, I did quite a lot of extra programming, adding new stuff to these devices. So in this case, I added in this auto playback behavior and auto record behavior. I tidied up loads of the user interface, improved the UI over here, improved the multi-slider control for the audio analyzer. Yeah, we've added auto recording and auto playback, and generally just tidied everything up so it's actually at the point you could send this to someone and not be entirely embarrassed by your work. Just checking the auto start position still works. It does, thank God. It's because I wasn't recording last time. So we've tidied everything up a hell of a lot. We have improved the user interface a lot. We have improved stuff with some multi-sliders and some labeling. We've added auto record and auto playback functionality. What we didn't get onto at all, as regularly happens it seems, is programming the LFO or adding sample drag and drop, which I think we're going to have to push back to next time, as I need to go and get some food rather than keeping on programming for even longer. But I think that might be a good time to wrap up after quickly checking if anything's actually working. Hopefully it is. Hopefully my computer hasn't had enough and just started glitching out, as it is wont to do at some points. Let's see. So we should be able to set up a nice scale with our scale probabilities, and we can actually switch to a different scale halfway through. I'm going to change this a bit because I actually like having those. Look at that, and I'm going to store that as preset 2 again. I'm going to add the octaves actually either side because, I just like having the octaves. We could do some complex programming at some point to have it auto shift these values over to where you actually put them. So that's going to play mainly, actually let's ignore the root notes because I just play the root notes. I don't care about the root notes so much. It's going to do a fair bit of octaves. It's going to do a lot of minor sevenths, 1 octave below and 1 octave above. Thirds, less important, quite a fair bit of fifths. Okay, that's a good pitch probability and it's linked to the pitches. I think that'll be good. Store that as preset 2. We could switch between our presets quickly and easily. Nice. And we can set up some auto recording stuff where whenever I do a transient, I want you to start recording and I want you to stop recording when the transient has stopped. I want you to clear the buffer, but I do want you to hold for 2 seconds. Check, check, check. Check, 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 check. So you should see when I'm clicking there, it's only starting to record again when it's been 2 seconds. Clearing the buffer has stopped working though, so that's one thing we need to fix. Pass through to a gate, bang through to you after the requisite amount of hold time. Go on. Are you working? Check. 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 What isn't working here? The gate is passing through. You should be getting a bang stored in here. Does a bang in the right outlet of a ZL reg not get passed through? I think that could quite be what's happening. Check. The bang is being passed through. The ZL reg is obviously not storing it properly. I lied. A ZL reg does not pass through a bang well, guys. Check. Check. Yeah. Check. So it is trying to pass it through. But apparently a bang in the right inlet does not get stored by ZL Reg. Why would you set that up? That is useless. So instead we're actually going to send the message clear. Check. And it sends a message to it again, triggers a message clear again. But screw it, that'll do for now. We might need to do some other programming at some point to tidy that up. But it should now only be clearing the buffer every 2 seconds if we've been recording for that long. We can also set up the auto playback so it plays around what I'm playing. Start point to 0. Bit of randomization around the start point just for fun. Bit of random on the timing, so the density is a bit randomized as well. Duration we'll put up to kind of a middle thing and add a bit of random too. Bit more random volume, bit more random pan. Down the volume a tiny bit. And we should be able to start playing some stuff in and have it automatically start granularizing around what I play in as I play in and harmonize it and record it into the buffer and all of this stuff. Let's hope it works. Oh. Why did you stop working, Mr. Playback? Optimize the pitch a bit more, please. This hold thing is kind of ending a little bit too quickly on the playback as well. So I think what we need to do is actually quickly, before we wrap this up, we're going to add this same hold parameter functionality to our playback, because at the minute the playback off is being triggered too quickly to let the granulation actually happen to a good level. So let's add that all the way up there. I think we always, oh Jesus. Right now I am actually talking about stopping it being able to off so quickly rather than stopping it being able to on so quickly. So in theory, although in the recording example, I think we just always want to be limiting how regularly it can start recording. We don't want to be limiting how regularly it can stop recording. In this example, it's a bit trickier. Because right now I'm wanting it to make sure the playback holds and doesn't turn off for a certain value, a certain amount of time. I'm not particularly talking about limiting how much the play happens. Next time we'll do some fiddling with this and we'll make it more complex if needed. For now I'm just going to make it control both, which we may find some issues with, and if we do we'll know we need to address them in the next video. Well, now we've definitely run out of space. I mean, that kind of doesn't make sense, does it? So now I think it's not going to let a... It shouldn't let an off through before 2 seconds. Check, check, check. Check, check, check. Let's minimize the full time so we can properly see it in effect. Let's minimize it way down, even though the check, 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 check. So that's passing through really, really quickly. Check, 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 check. Yeah. Check. 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 Oh, but now the play on is always stopping it holding the off correctly. We're going to need to do some weird work on this to allow the hold time to properly limit either the on or off, and they are switching each time, which makes it even slightly more confusing to wire up. What we're going to actually want to do is probably put a root here and root a 1 or 0, because these can change over time whether they are sending the transient is triggering an on or an off. And at least in my head for now, I can only think of occasions where I'd want to limit the off. I don't think I'd want to limit it playing so regularly. I could probably deal with fiddling with that in other ways. I think just to get this example working at least, I'm going to want to apply hold time to playback offs. I'm going to want to pass through playback ons all the time, uninterrupted. Let's get that cable out of the way. The old Command Shift Y cable, auto cable alignment trick. So now the hold function will only apply to 0 or offs, which is good for play. On the record, the hold function is actually only happening to record ons. We might need to add some other menu or something fancy or some link to this menu here so the hold function applies differently depending on what setting you've applied. But for now, let's just test if this example works. Now I should be able to say something and have it granulize. Let's check if it's working. Yellow. Check. 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 It's definitely not working. Route 1, pass the message on. Of course. Whenever you route a 1, you actually delete it. This needs to be a route pass message. Big brain business. Route pass rather than deleting the 0. So route message, it selects the word, passes on any messages after it. Route pass actually passes on the message itself as well. So in this case that should work. Check. Let's see if it works. our nice alternate kind of side-chained version. Scales applying a little bit too much extra harmony. Let's switch back to our non-scale focused pitch preset. Go wild with more grains. Let's go wild with more grains. Oh, it did not work. Let's try 1 sec again. Gotta reset all this stuff, I think. before I get lost messing around, making weird dub chord textures with the melodica and this auto recording granularizing business. So yeah, we did a hell of a lot of tidying up. We added in autoplay and auto record functionality, making better use of the transient analysis, transient detector we built. We added in some hold times for that, automatic clearing of the buffer, bit more work to make it all super nice and tidy. But yeah, most things seem to be working and usable. We have an incredibly simple basic LFO still. I'm sorry we didn't have time to fix that, but we did actually have time to do most of the work I did myself yesterday and get to a point where we're pretty much back up to the same point, which is good. We just need to work on making that LFO, which admittedly in the last video, or when I did it myself yesterday, I actually just copied in an LFO I'd already programmed in another project and just copied it in. But I wanted to in the video actually run through programming an LFO from scratch, which unfortunately we didn't get time to do. And I promise after that we'll probably actually get to the point where we drag and drop samples in. Directly just drag samples onto here to load them in. And on my own time, sometime before the next video, I'm going to do some work making a nice display for the grain playback. At the minute, when we're recording into the buffer, we get a visual representation of where that we're recording and where we're recording in the buffer with a nice red line scrolling through. We also want a display that shows us grains, what grains are playing, where they're playing in the buffer. Just a nice visualization of that might be useful as well. So we can have a number of grains up to I think 100 you could enter into here. We could have that be anything, but obviously you'd start using more and more CPU. For now we've pretty much left it so you can only ever have 50 grains at a time, and that's kind of fine for most cases. But what we'll do is we'll design a kind of similar system using this, I think we're using a fader or something here to scroll through, but we don't want to have to drag, say, 50 of these fader objects and map them all up. We want to do something a bit cleverer. We will probably use the jit.lcd object or some kind of JavaScript user interface object, which will allow us to draw these little rectangles effectively, these little sliders, as they move along the granular object, and we'll make it so they kind of resize or change color maybe as they go through the envelope, so we can kind of look at their loudness and have a slider appear when a grain is playing, where it's playing based on its playback position and randomized start position and all of that stuff, and have them kind of change for what shape maybe. They'll probably be green, I'd guess, and they'll change from being a lighter or darker green as it moves through the envelope, and it will display properly rather than a sample playback. So we'll do that. We'll build an LFO, we'll do drag and drop sampling, and we're kind of getting to the point, after a lot of tidying up today, where this is kind of getting near something actually usable and releasable to give to your friends or to the public. So yeah, hopefully not too boring showing all the sides. The things with Max involved in tidying up and trying to make a bit of a better UI, but it is necessary when you're programming. So sorry we didn't get into the LFO, but we'll do that next time, and hopefully drag and drop sampling. But for now, I think we've got a hell of a lot further along. The autoplay and record is kind of working. We're making better use of the audio analyzer, and we just have a hell of a lot of a nicer device to play with. So that's good. Going to let it ring out with one more dub chord, because I'm really just liking them too much for my own good, probably. Oops. Sounded pretty nice. Cool. That is it. Serves me right for leaving my new autoplay functionality on. That will do us for this time. I've also started uploading all these videos to YouTube, so all of the last ones are on YouTube. This one will be up on YouTube sometime today or tomorrow. For now, it'll be on Twitch to watch back in HD. Thank you, anyone who's tuned in. Hope it was interesting. Hopefully it'll be more interesting when we do all the LFOs and other stuff next week as well. And we're pretty near finishing this series of videos, moving on to some other stuff. If anyone has any suggestions, give me a message or write them in comments somewhere. But for now, I'm done. See you next week.